Hey everyone, this is Mr. Mullen for part 2 of this video. So 6.1 properties of exponents. So if you're just watching this one first, I would go back and watch part 1. So we're going to go through some of these problems in our note packet here. So they're all kind of a little different. So we have first one, 3 to the 0 power. If you remember, anything to the 0 power is 1. Just like number 2, negative 2 to the 0 power is 1. Okay, 3 to the negative 4th power. So remember, I would figure out what 3 to the positive 4th power is first. That's 81. So 3 to the negative 4th power is 1 over 81. Okay, same thing here, negative 4 to the negative 3rd power. So that means it is negative 64 because of the negative 4, not because of the negative 3. So that means I'm at 1 over negative 64. Okay, here I have 2 to the negative 3rd power times 5 to the 0 power. So now we have a 2 to the or something to the negative power, but now it's in a fraction. So if you look here, we kind of flip it around. And so that's what we're going to do here. We're just kind of going to flip it to the bottom or flip it to the top in whatever case. So we'll just leave a 1 up there. And then we have 5 to the 0 power times 2 to the negative, or 2 to the positive 3rd power now. So when we flip it, it becomes positive. So 5 to the 0 power is just 1. 2 to the 3rd power is 8. So we get 1 over 8. Okay, same thing on number 6. So we're kind of just flipping it. So the negative 3 to the negative 2 power goes to the bottom. The 2 to the negative 3rd power goes to the top. So now it should look something like this. 2 to the 3rd power, negative 3 squared. So 2 to the 3rd power is 8. Negative 3 squared is a negative 9. So negative 8/9. So kind of like we did here, we flipped it from 81 to 1 over 81, negative 64 to 1 over negative 64. It's the same thing here. We are flipping it. Okay, so let's flip this again. So 4 to the negative 1st power flips to the bottom. We don't have to flip that 0 because it's not negative. So now we have 1 over 4 to the 1st power times negative 7 to the 0 power. Well, 4 to the 1st power is just 4. Anything to the 0 power is 1. So we're just left with 1 over 4. Same thing with number 8. We're flipping it. So it becomes 1 over 3 to the 1st power times negative 5 to the 0 power. Again, anything to the 0 power is 1. 3 to the 1st power is 3. So I end up with 1 over 3. Okay. Now we have some with exponents. So z to the 0 power is 1. Remember, it doesn't matter what z is, even though we don't know what z is. Anything to the 0 power is 1. Now there's some exponents in here. So a to the negative 8th. So let's pretend it was like a 3 or something to the negative 8th. We would flip it. So 1 over a to the 8th. And we can't do anything else after that because we don't know what a is. If it was, we knew a was 2 or something, then we can do it. But unfortunately, we can't. Okay. Same thing with like 11, and it looks like some of these next ones going on. So b to the negative 2nd power. So 6 has an exponent of 1. That's good. It stays on top. A has an exponent of 0. That's good. It's not negative. And b has an exponent of negative 2. So anything with a negative exponent is going to switch sides. So that means I have 6 really to the 1st power, a to the 0 power, and then b squared. So it's switching from the numerator to the denominator. Okay, and then let's simplify. So 6 to the 1st power is 6. A to the 0 power is 1. So 6 times 1 is 6 over b squared. Okay, same thing on number 12. 14 stays on top. It's good to go. It doesn't have a negative exponent. M to the negative 4th, however, does have a negative exponent. It needs to switch sides. So m to the negative 4th switches to the bottom to become m to the 4th. N to the 0 power just pretty much goes away because it's 1. 14 times 1 is 14. Okay. 13, we have a 3 to the negative 2nd power. That needs to switch sides. We have an r to the negative 3rd power. That needs to switch sides. And we have an s to the 0 power, which is just 1. So if I'm rewriting this, I'm left with 3 to the negative 2nd, 3 to the 2nd now, times r to the 3rd times s to the 0. And we can kind of just simplify that. 3 squared is 9. r to the third, we don't know what r is, so I'm going to leave it as r to the third, and s to the 0 is 1, so times 1. Okay, 14. So 2 to the third power can stay on top in the numerator because it's a positive 3, but a to the negative third power can't stay there because it is a negative exponent, so it needs to switch to the bottom. 8 to the negative first power has a negative exponent, so that needs to switch to the top. And b to the negative fifth has a negative exponent, so that needs to switch to the top. C to the 0 is not negative, so it can stay there. So I have 2 to the third power on top. And then 8 switch, so 8 to the first power. And then b switch, so b to the fifth power. A to the negative third switch to the bottom, along with c to the 0. And now let's simplify this. So 2 to the third power is 8. 8 to the first power is 8, so 8 times 8 is 64, times b to the fifth power. And then a to the third power, and c to the 0 power just goes away because anything to the 0 power is 1. Okay, I would say those are probably the hardest. So if you're like looking at me, you're like, Mr. Mulla, those are really hard. I agree with you. Those ones with the negative exponents are tough. Just remember, kind of like up here, if it has a negative exponent, you're really just putting a 1 over it, and it is becoming positive. Just like you did with 3 to the negative fourth power, it became 3 to the positive fourth power. And 3 to the positive fourth power is 81. Or any of these other ones. Negative 4 to the negative third power becomes 1 over 4 to the third power. So we're just flipping it around. So it either goes from the numerator to the denominator or the denominator to the numerator. Okay. The rest of these shouldn't be too bad. So 3 to the fifth power divided by 3 to the third power. So remember, here we subtract. 5 minus 3 is 2. So we get 3 to the second power, or we get 9. Same thing here. 2 to the seventh, or negative 2 to the seventh power over negative 2 to the fifth power. 7 minus 2, we get 2. So 2 squared, or we get 4. Okay, same thing here. Negative 5 to the third power times negative 5 to the third power just ends up with negative 5 to the sixth power. Okay, 18 and 19, it looks like we have a power of a power. So that means we're going to multiply those. So 5 times 3 ends up being q to the 15th. Okay, here we have a to the negative fourth times 2. That ends up being a to the negative eighth. But again, now we have a negative exponent. So the opposite of a to the negative eighth is 1 over a to the eighth. Okay, 20, it looks like I have C4 and C3. That makes C7 divided by C6. 7 over 6, remember we're subtracting those. It's really just c to the first power, or c1. And then remember with these, it goes to both. So negative 4 to the fourth power and d to the fourth power. And whatever negative 4 to the fourth power is, we figured that out before, it's 256. D to the fourth power. Okay, same thing here. The negative 3 is going to go to both. So that means I have negative 3 to the negative 3 power and f to the negative 3 power. But wait, since they both have a negative exponent, they're going to switch sides. So they go down from the numerator to the denominator. So then we end up with 3 to the negative third power over f to the third power. And then for the last one here, we have 4 over x to the negative third power, and remember that negative 3 again goes to both. So 4 to the negative third power over x to the negative third power. Again, wait, both of them are negative exponents, so this is going to be a straight flip-flop here. So the 4 is in the numerator, it flops to the denominator. The x to the negative third is in the denominator, it flops to the numerator. So that means x to the third power over 4 to the third power is my final answer there.